Hello and welcome everybody to the Vue Meetup Online. My name is Simone Cuomo and I'm a senior software engineer at this.labs. Our sponsor today is this.labs, your partner in modern digital transformation. We specialize in mentorship, consulting, training, and staff augmentation for enterprise organizations. Find out more at this.labs.com or send us an email at hi@this.co. The year is finished. This is the last event of the year, guys. But next year, we already got a fantastic lineup with the JavaScript Marathon on the 20th of January, the monthly mentoring session with Women in Tech, again on the 20th of January, and then the Global Vue Meetup with the State of Vue community on the 21st of January. So I really look forward to meet you all on the first events of the next year. Today, we got two fantastic speakers. We got Tracy Lee, that is CEO of this.labs, and we got Mike, that is a developer advocate at Ionic, both on the screens and ready to rock. So our first talk is going to be from Tracy, and it's titled From Beginners to Expert in Web Performance. And then we're going to have another talk from Mike that is called Building Cross-Platform Application with Vue and Capacitors. As you all know, if you already joined this talk before, for everybody, the talks are around 20 minutes each. We usually ask people to write comment in the chat. We're able to read the comments to the speakers, and we usually like to answer questions at the end of the talk. So if you have any question or anything at all, I will be there to support you guys. But for questions to the speaker, let's wait for the end of the talk. And without further ado, let's crack on with our first talk with the fantastic Tracy Lee and talk about web performance.
Thanks for having me. I'm so excited to be here today and talk about web performance. But you know, the crazy thing about web performance is the more you know you don't know. So that's where life has been these days. So even as I go through this, you know, I laugh because the title of this talk is From Beginner to Expert, and I'm like, oh yes, but I learned 3 new things yesterday about web performance. So now this talk is out of date. But anyways, we are going to talk today about how to become a web performance expert. And I'm going to show you how in just, you know, some really easy steps. So let's go ahead and get started. Like Simone said, my name is Tracy. I'm the CEO of a company called this.labs. We do JavaScript consulting, so we are framework agnostic. We love all technologies. We have experts in all of them. I'm also a GDE for Angular and the web, a Microsoft MVP. I'm on the RxJS core team. I'm a Women Tech Makers lead as well, and I run a few different meetups. So, you know, life is fun. All right, so today we're going to talk about measuring web performance the right way. Then we're going to talk about creating a foundation for web performance, also measuring web performance in DevTools and Lighthouse, certain key Lighthouse metrics as well, and 2 super easy web performance fixes you can do in your sleep. Now, you might have already opened up Google Chrome DevTools and ran a Lighthouse report, but there is so much more to understand, and you could also be getting misleading metrics. So let's get started talking about that. So one of the most important things that you need to do, even before you get started with web performance, is understanding your users and customers. Alex Russell, who's known for web performance at Google, he recommends you look into high percentiles of slowness for your customers. And even if you can't get good population level data, if you can't get good population level data, then you should just assume that you're making tech for the disenfranchised. And, you know, Chrome Dev Summit was I think it was last week. And, you know, there's been a lot of new exciting tools that have come out. So I'm excited to talk about that in another one of my talks, hopefully I give in 2021. So once you've decided on your demographic, right, it's really important to kind of figure out what you're optimizing for based on that demographic and create that foundation for yourself. So the first thing you need to do is really make sure you're defining your goals, of course, right? measure the right thing. Every company has different goals. Don't let other metrics define what your goals are and what you should be optimizing for. The second thing to do would be really to make sure you have a set of baseline metrics so you have something to measure from. And then you can really decide which levers you want to move and what numbers you want to improve. The third thing to do is always make sure to measure across multiple devices. You never want to just measure on your machine. And if you don't have access to multiple devices, Chrome DevTools allows you to simulate various devices, which is really amazing. And if you do just need to start somewhere, right, then you can always just start by assuming that you're building for the disenfranchised. Now that you've created a foundation, it's good to just get started. So let's go ahead and get measuring. Now, in the next few slides, I'm going to walk through how we typically measure performance across different sites on the web. And what I'm showing you a lot of is, unofficial industry standard. And also a lot of what I'm showing you is also just opinions we formed about performance based on the work we've done. So take it for what it is. But let's first talk about just how to effectively measure web performance using Chrome DevTools and Lighthouse. So there's a few steps that most don't consider before measuring performance in DevTools and before running a Lighthouse report. But these are the things that you should do. So the first thing to do is make sure that you're opening up your production application, not dev, not local, and do that in an incognito window, right? The key here for the incognito window is to make sure that any extensions that you have aren't getting in the way of your measurements. The next thing you want to do is make sure to change your device that you're measuring in DevTools to Moto G4. This tends to be the industry standards from what I've seen. And you should do this if you're running performance benchmarks on sites. So now also make sure you're actually throttling your network, right? Of course, your site is going to be super fast on a high-speed connection, but that's not going to be the typical experience of your users out in the wild. So making sure you throttle your network speed to slow 3G. Now, the other thing is most people are not running sites on the supercomputers that some of you may be developing on. So making sure to throttle your CPU to 4x slowdown to accurately benchmark your site is really important as well. Also, making sure you are disabling your cache as well in the network tab, right? Otherwise, your site is going to appear faster than it really is for users who have never been to your site. After this step, then you are ready to get started measuring. So go ahead and hit refresh so you hit your site with no caching. And then you can accurately run a Lighthouse report, and that'll give you a realistic benchmark. Here are the steps again, just so you know kind of like all the steps that you should take to, before you run a Lighthouse report. Now that you've run it, it's kind of, now you're kind of wondering, okay, I have this Lighthouse report. What do I do next, right? So I'm going to walk through a few key Lighthouse metrics. So there's 6 different key Lighthouse metrics that you need to be considering. You have FCP, LCP, CLS, TBT, TTI, and SI. So let's go through this really quickly. Let's talk about first contentful paint, or FCP. So this measures basically how long it takes the browser to render the first piece of DOM content after a user navigates to your page, right? What does this mean? That basically just means, hey, how long is it going to take before a user actually sees anything? Now, baseline, and I really love all the tools we have available to us. So web.dev gives you some really amazing information and also baseline numbers. So sites typically performing in the 99th percentile render FCP in 1.5 seconds. So that's a really good measure of, if you're trying to figure out what should my FCP be. That's a good baseline number. The second thing is largest contentful paint. And this basically means, hey, how long is it going to take before a user actually sees the largest thing that loads on your page in the viewport, right? And typically speaking, that should occur within 2.5 seconds of a page starting to load. And yeah, again, like if you check out web.dev, there are some amazing, they go pretty deep for some of these things. Cumulative layout shift, I love as well. This actually measures when the browser has to resize, move, or recalculate layouts on a page. And you should be making sure that you have a CLS score of less than 0.1. And, you know, if you do that, I mean, I can't tell you how many times I've loaded a web page and something's jumped and I've said, okay, you know what, I'm just going to abandon this. So cumulative layout shift is really important. Time to interactive. This basically talks about the amount of time your site takes to allow users to interact with it. So this is basically the difference between first contentful paint and time to interactive, right? The difference between the time somebody actually sees something on your website to the time that somebody can actually use your website. And, you know, a really big thing about web performance, right, is definitely not just how fast your site is from a metrics perspective, but specifically how fast users feel like your site is. So FCP and TTI, and the difference between FCP and TTI are to take note of. Total blocking time. This again is like how long a user has to wait. But, oh, you know what? I got those wrong. Sorry. Time to interactive. Anyways, I digress. But total blocking time should be basically less than 300 milliseconds, right? And that's when you're testing on average mobile hardware. Speed index is, I believe, the last one I'm talking about. And this is just, you know, hey, how fast does your site actually look? So making sure that you have a speed index of between 0 to 4.3 seconds, and that'll get you a Lighthouse score of 75 to 100. 4.3 seems, you know, pretty slow, but at least, you know, Google's giving us some level of okayness if we can't get, you know, 0 for the speed index. So again, these are the 6 kind of metrics that you should be looking at, but Google did just release, well, not release, but talk a lot about Core Web Vitals. And I believe that consists of either 2 or 3 different metrics. And, you know, Page Speed Insights is a really, really good place to go as well to kind of check out how your website is performing. So there's just a lot of amazing tools. And I think one of the great thing about being a developer is like the further you Google, the further you go down the rabbit hole, the more information you're able to get. So I wanted to also talk about just like super easy things that you can do to improve web performance in your application. So if I had to focus on 2 things that I could do today, right, by looking at Lighthouse, it would be large images and unused JavaScript. So images, there is so much web performance content out there just talking about images. Like if you search web performance, you might have a hard time finding anything that's not about images, right? So unoptimized images are a huge problem that make the web super slow. And Lighthouse actually tells you how big images are and what you can reduce, right? Also, loading different size images based on the device being used is really important. Making sure all your images are under 100 KB. Setting the source in image tags for browsers. Setting the source to source set in image tags for browsers that actually support this, because with source set, you can actually define different sizes of an image and let a browser select the image source based on the size for you, which is really, really useful. The second thing I would recommend is just dealing with all your unused JavaScript. Again, super easy to fix on your site. Lighthouse, fortunately, just gives you a list of unused JavaScript. So you can just go down the hit list and fix your site, right? You can also go to DevTools, go to the console. If you hit more tools and click coverage and then hit record, if you actually start using the site and stop recording and then kind of look at the results of the usage visualization, the usage visualization will actually tell you how much unused bytes per resource is actually not being used. And that's actually extremely helpful. So that's the little image I'm showing right here. So I know this was a really quick talk. It's just kind of a quick like, hey, this is how you can easily get into web performance. But I do want to mention some caveats as well, right? Lighthouse reports are not everything. Again, there are so many amazing tools out there for you. PageSpeed Insights, again, is an amazing tool. But you should definitely make sure that you're optimizing your metrics and performance based on your company's needs and goals. Just because Lighthouse tells you something is not right doesn't mean it's not right, right? You're going to have to determine that as, as a team. And also, without understanding what you're optimizing for and just micro-optimizing for a good Lighthouse score or trying to, hack the Lighthouse score, it might actually end up hurting your goals versus helping. So the real question is, should you optimize for a Lighthouse score of 100? And I would definitely say it just kind of depends, right? But if you really want to, there's this really cool thing that Google put out, and the link is on this slide right here. And you can always check and see how Lighthouse actually scores everything based on your device. So you can change the device up top, and it'll tell you like, hey, here's the weighting, here's the value, etc. So it's a really, really useful tool to use. A few things we learned today: measuring web perf the right way, creating that foundation for web performance, using DevTools and Lighthouse to measure a few things. We talked about key Lighthouse metrics, 2 super easy things you can do literally today by running Lighthouse and just fixing your images and unused JavaScript. So check all this out. Let me know what you think. You can always find me on Twitter at Lady Elite. And, at this dot, we host tons of different free events. We do a podcast called the Modern Web Podcast, and we're having a lot of talks these days about web performance. So check that out. I just did a podcast with Alex Russell, who is the tech lead for Project Fugu, who, he's in charge of all the new web APIs that are coming out for Google. Quite interesting stuff. And we also have another show called Speed at Scale you can find on our YouTube channel. And that is pretty interesting because we go into profiling sites and different things like that as well. So thank you so much for listening. I hope you all enjoyed, and I hope you guys get excited about web performance and tell me everything that you're learning.
Amazing. Thank you so much. Amazing talk, Tracy. Tracy, do you any chance you can share the link of the scorecard? I was trying to copy it for the audience.
Yes, I will. Hold on a second. The link of the scorecard. Which one?
That one. Yeah, this one.
Yeah.
If it's possible, just because it's...
Yes, I'll copy paste it.
Amazing. Thank you so much. Yeah, it's easier to do it in the comment of the YouTube channel.
Yeah, no problem.
Good. Amazing. So has anyone got any questions in general, guys? Anything they would like to ask Tracy? There's a question about the speed. So you did mention a speed of Moto G4. So what was the drive behind the speed that you've chosen?
You mean why Moto G4?
Mm-hmm.
So Moto G4 is it's the actual device, and I don't know why it's become the industry standard. But if you ask other web perf people, right, when they're thinking about measuring websites and performance, they're always benchmarking against Moto G4, the device. I think it's because it's just very widely available and a lot of people are using it.
Yeah, and also very slow, I think. So it's always nice to benchmark. It's always nice to benchmark for something that is not the high end, because like you mentioned in the talk, it was very good mentioned, is we use our very high performance machine and we think everything works, but we need to remember that our customers don't use those. So amazing. Thank you so much. So thank you for the talk, Tracy. And now it's time to call our next speaker, Mike.
Hello.
So, Mike,
I decided to get very festive with the beer.
He waited for the audience before he goes festive. I love that
thing that you are saying.
We can hear you.
It's okay.
All right, there we go. I don't know what happened. My audio was cutting out.
He cannot hear. No one in the audience can speak. So I'll leave everything to Mike. Go.
Okay, cool. So, hello everyone. Yes, welcome to the talk. Um, I have my lovely beard ornaments for the festive holidays. Hope that you all have a good rest of the year. 2020 has definitely been an interesting year, but one of the big things that has been, kind of forced upon us with 2020 is the need for building cross-platform apps. I know that I have been working a lot with cross-platform for most of my career, so I want to talk a little bit about this and start by defining some key ideas like what is cross-platform at all. Interesting enough that when you talk to developers about cross-platform, some still aren't quite sure what cross-platform actually means or what problems that it's trying to solve. So it comes down to these three ideas. Write once, run anywhere. I want to be able to take whatever code that I am writing and deploy it to multiple devices or multiple runtimes, whether that be an iOS device, an Android device, or the web. In addition to that, there's also this idea of an abstraction, being able to write something for a device or for a runtime and have a common abstraction to handle the differences between these platforms. I shouldn't be able to call one native API or something like a file system API, or I should be able to call this API and have it run across all these platforms, knowing that the API should be able to account for the differences in, say, iOS and Android, or for the web. And again, kind of really coming down to it is there should only be one code base. People should not be able to, should not have to manage multiple code bases, multiple code platforms, multiple different changes here and there. They should be this emphasis on I code in this one code base, and then I can just deploy to these different targets. And this all sounds really great. If I were to tell you what cross-platform development is without you having any knowledge about it, you would say that sounds great. That sounds like what we should all be doing. But the truth is that this is not the norm for everyone. A lot of people still aren't quite sure if cross-platform is worth it. A lot of people are not sure if you can actually achieve these goals that are can achieve these goals that cross-platform tries to solve. So to look at why these ideas kind of exist, let's kind of just take a quick little history lesson. So roughly 10 years ago, actually a little bit more than 10 years ago now, we've had the very first iPhone and iOS SDK. We had the very first Android SDK, and we've had all of these different improvements to native development. If you were to develop a native app today, you probably have a lot of great tools and great IDEs and editor supports that you just don't normally get. Developers did want different options, though. Originally, if you think about the very first iPhone, the promise was that we would ship web apps, not necessarily native apps, because writing a full SDK is very, very time consuming. But they shipped a native SDK, gave everyone a new language to learn, and the rest is history. Developers have always wanted different options, though, and there were a group of developers who started off on this idea of cross-platform development and what they called hybrid development, and that is the lovely folks over at Apache Cordova. Now, Cordova started off as a project called PhoneGap, created by some developers up in Canada. It got donated to Apache, called Cordova. Adobe bought PhoneGap and kept the name. So there's probably different names, but if you call it PhoneGap or if you call it Cordova, don't worry, it's the same thing. So they really pioneered this idea of write once, run anywhere, and they are probably the very first people to do so. Basically, they gave you this runtime or this bridge layer that would allow you to take your JavaScript and run it inside of these native devices and polyfill certain APIs that didn't exist. All with the goal to cease to exist, because their idea was that the browsers would implement all these features natively. They basically gave you this web view that you could load inside of a native app and call out to things like the device's native camera, the file system, geolocation, Bluetooth, all before the browser ever shipped an API. And that's really great. It allowed us to do these pretty cool things where we had, say, this camera object where you could say, get the picture, and then on success, handle that. On failure, also handle that. And here's some options to pass along to this camera call. Where it kind of got a little quirky was that they had this, little handshake delay between the web view and the native operating system. So they had to have this custom event called device ready, where if we wanted to say, get the geolocation on startup or get access to the file system on startup, we had to wait for this device. So there was like an implicit, 500 millisecond delay guaranteed. So, while that is quirky, it is what it is, and we can kind of move on from it. What it did well, though, was kind of grow this whole idea of write once, run anywhere, and actually target different platforms. So we had iOS, Android, but there was also support for Windows, Electron, Mac OS. If we went back, 5-6 years ago, there was support for things like BlackBerry, Tizen, Symbian, WebOS, all these different platforms that are no longer with us. They also encouraged a lot of community members to build their own platforms and plugins and kind of build things that didn't make sense in the core library or in the core project. They really built the community up and tried to get a lot of people involved. And they also treated native as a build target, meaning that developers shouldn't need to know how to build with Xcode or Android Studio, and that they should just be able to run a command from the command line and get a native binary from that. So, it did some really good things well. Unfortunately, it also did some of these things pretty poorly. In hindsight, custom tooling for everything, there was no NPM at the very beginning, so they implemented their own package system, which was very prone to errors. And once NPM or node packages started becoming the more common thing to do, they were pretty slow to adopt. The volatile project structure was a result of people wanting to keep the native platforms not part of version control. So, I mean, if I were to make some changes to a project, commit that to version control, a coworker to clone that project, they would not get these changes, and they'd be kind of left to re-implement a lot of them. So projects were often just deleted, rebuilt all the time, and left to this inconsistent variety or inconsistent state between computer and computer. And treating native as a build target. That was a positive in the last slide, but it's negative here. Why? Well, as the native platforms have kind of evolved, and we have a lot, and they provide a lot better mechanisms for adding things like entitlements, push notifications, background services. Adding those to a native project is a matter of flipping a toggle. When you remove the native project from the equation, you now have to have custom tooling to be able to re-enable that every time you add a platform. So it's this kind of snowball effect of once you remove these native projects from the equation, well, now you have more tooling, you have more error-prone software. It's just not ideal. So moving on from this, some people decided to try to solve a lot of these issues and also do it in a very different way. And this led to the rise of this, what I would call compile to native. I think the biggest proponent of this is React Native at the moment, where they said, write once, run anywhere does not work. What can we do different? And they brought the idea of learn once and write anywhere. If you look back, there's actually a great talk from Rob Osell from This Dot, who talked about React Native and some of the ideas and tutorials that you could use to get started with React Native. And the idea was that you had this common abstraction and this common API, and that you would reuse that for all your different platforms. So you would not necessarily have, you'd have some common abstractions, but you would also be expected to maintain separate projects. And this really brings the idea of abstracting the lower level pieces of UI, but not necessarily abstracting all of it. They really just focused on the controls that people would interact with. They give you this promise of a truly native app, but really all the code is just interpreted inside of a JavaScript VM and then renders the native UI at runtime. Architecturally looking, it's pretty similar to, say, Cordova, where there is a JavaScript app, but instead of loading it inside of a web browser, we're loading it inside of V8 or JavaScript core on iOS. The bridge layer and the communication between all that is fairly similar. There are some nuances to this because you can embed and intercept all of these calls and add more native code. But from the very basic hello world, this is what it kind of looks like. Now, code-wise, we're going to look at React Native. Even though this is a Vue meetup, it is nice to know. Well, the actual code for this, it doesn't really give you an idea of what you're rendering. It gives you the abstraction. So a view roughly translates to a div, and text roughly translates to a paragraph tag. But if we want to do anything, I think, more compelling, we need to bring in a third-party library like Expo, where we would say, render a camera view and style it this way, give it a back type of camera, so always show the normal camera, not the front-facing camera, and render this to the DOM. This code being having implicit knowledge of I am on iOS, I should use the iOS native camera calls, and when loaded on Android, I should use the native Android calls. So there are some good sides to this, but there are also some downsides to this, as we'll look at later. What it did well. React Native, what it did well is really giving you access to the native project. If you wanted to modify that at all, you could make those changes and know that they were going to be persisted to version control. The native architecture between the runtime, the web runtime, and then the native code, that was really good. It made use of modern JavaScript or modern native tooling and modern native plugins and libraries, things like CocoaPods on iOS and Android libraries on Android. So it really made sure that that layer was really well done. What it didn't do well is a few things. I'm going to point out community building, mostly because that you do not see a huge amount of React Native devs as you do just React web devs. Why this is, who knows, but it is something to point out. The uncanny valley of native knowledge. If you're a developer, you might need to know how to dive into the native code, which might not necessarily be something that you want to do. If you are just a web developer, you should just be able to build something with just JavaScript or just HTML. And in doing that, they also kind of removed the web at the very beginning. There are some efforts to bring that back in, but they're not necessarily the main focus of the project. Now, this is a pretty not extensive list, but all kind of cross-platform runtimes at the moment have the same problem, and it raises the question, is cross-platform just not really worth it? I would say no, and I would say no because of this project that we are working on called Capacitor. Capacitor is a reinvention, I think, of a lot of the ideas that we saw from Cordova, but also some ideas that we've seen in React Native to give you a better abstraction around what we're calling web native development. Architecturally, it's fairly similar to how Cordova works, where there is still a web view, but the details and kind of overall plumbing of how this works are much closer to something like React Native. And we can look at that in a little bit. You do need to bring your own components. So Capacitor does not give you the components or the visual UI. So you would want to use something like Ionic, Angular Material, Vuetify, any other Vue libraries that exist out there, or roll your own library. For the APIs, they are not 100% web standard or follow the web standard APIs, and we can look at that in a second, but it allows you to actually better adapt to the different platforms. And it gives you instant access to the native APIs when they become available. And what does that mean? That means there's no implicit delay. There's no device ready event that we need to wait for. We get access to that right away. So with that, let's kind of go over to my editor real quick. And I only have a few minutes, but I want to kind of show you some of the key parts here. So I'm opening up an editor, and really we just have a Vue project here. It's using TypeScript, but we just have a Vue project. It's using Ionic. It doesn't need to use Ionic if you don't want to. It's just what I'm comfortable with. Inside of here, we have this tab component, which is just a page that you can load up. Now, inside of this, we have a couple different methods here that we are going to use, or functions that we're going to make use of. We're going to make use of this make directory or make dir function and this read dir. Now, they're using this thing called file system. Now, what is file system? Well, file system is Capacitor's file system API that we can import from the Capacitor file system package. Now, this is all using a pre-release version of Capacitor, so please refer to what the usage is on the Capacitor docs. But basically, we can just say, hey, if there is, if you can, make a directory called notes and make it in this documents parent directory. And we can do the same thing with read directory, where we can return an array of files that exist in the notes directory, also located inside of the documents. Now, on init, we can say, all right, make a directory if it doesn't exist, no op if it's successful, or no op after the directory has been made, and if there's any issues, then we can call read dir. And then after we get a list of all the files, we can just render that out to the screen. So instead of talking, let's just run serve. I could run Ionic serve since this is an Ionic project, but we're just using Vue at this part, or at this point. So let's just run npm run serve and start up the Vue CLI service. Now, I'm just going to navigate to say localhost host 8000. Localhost 8080. I'm getting old and I cannot see the URL from this far away. So basically what we have here is a little note-taking app that I've been building where I can say, all right, I'm going to create a new note. I have a rich text editor here and I can say things to buy, milk, bread, and eggs. And I'm going to do some formatting real quick. Bear with me while I try to figure this out from all the way over on this side of the screen. Okay, so I know I've actually, all right, this looks good. Cool, so let's save this file. And notice that we now have a little note saved here. And just to prove that this is writing an actual file, let's just kind of do a hard refresh. Hard refresh again. Let's open up a new window altogether and know that this file is being saved to the file system. We can check it out a little bit later. We can go into it. All right, I've already bought milk and bread. So let's cross this out and save that and come back to the actual file in a different window. And these should still be crossed off, even though we're not persisting it. It's because we're actually reading file and reading data from our file system. Now, this is cool for a couple of reasons, but mainly because I didn't have to know any of the details about a file system altogether. If we come over to, say, Android Studio, we could run this same app on our device, and without literally changing any of the code, we'll let it do its thing real quick. Yeah, launching activity. We should automatically be integrated into the native file system that ships on native Android and not just a web implementation of a file system. Let it do its thing. And if this doesn't want to work, well, that's a bummer. what we can do instead is really quickly npx open npx sync. We'll do npm. Here we go. Do we want it to support this? Allow. Come on, Android Studio. Without going too far and spending too much time on it, we'll let it do its thing. It looks like it allowed me to write to the file system. Let's open up a note taker. Android Studio might be chugging along because we are streaming, so I'm not going to spend too much time on this. But note that the file system and APIs that we have available here are using the native implementations, just the code has adapted to these different platforms. So we get a nice little mix of being able to support native and support the web, all from the same code base. And yep, the editor opened up. So let's type something. If we can actually type, this is painfully slow, Android Studio. This is so sad and disappointing. Okay, we'll keep on going and not worry about it too much. But we'll go back to the slides and kind of focus on that for now. So we saw the demo briefly, real quickly. This is going to be up on GitHub, so definitely check out the links for it when I publish it. But right now, we could also deploy this app to obviously Android and the web, but also things like iOS. And this would allow us to embed all these native device features without having to actually maintain them or write them ourselves. We just have this one common API to develop against. If you wanted to support something like Electron, there is support for this in a community platform. But we really think something like web development and PWAs are going to be replacing desktop development with Electron soon. Quick little bit, if you are trying to work with this, we only support Android 5.0 and up, which is like 90% of Android users, and the last two major versions of iOS. So this includes iOS 12 and iOS 13, as well as iOS 14. So think of it like N-2. If you wanted to add this to your project, you could just install capacitor core in the CLI and then run npx cap init. And then for framework support, right now we have documentation and guides for obviously Vue, React, Svelte, Angular, and also support for things like no frameworks at all. Now, kind of parting thoughts here is this idea of web native. Capacitor really gives web developers the tools that they need in such a unique way that it's no longer just hybrid development. It's building web apps that can run on native without having to sacrifice any changes. It's really the kind of runtime for modern developers, and we think it runs the right abstractions in the right place. We're definitely pretty excited with it, and we really want to encourage other people to try it out. We looked at it with Vue, but if Vue is not your thing and you want to try a different framework, no worries. Capacitor can integrate well with that framework. So with that, I want to wrap up. Thank you so much for coming here and hearing me speak for a little bit. If you have any questions, feel free to reach out on Twitter. My handle is mhartington. And if anyone has any questions, feel free to put them in the chat. Definitely want to go over them.
Amazing. Thank you so much, Mike. I should have warned you that StreamYard takes quite a bit of energy from your machine. I did completely the same last month. I tried to run npm install while I was on the talk, and it failed miserably. Very bad.
I really kicked myself because I should have had Xcode open. Android Studio is just so painfully slow, but we can see that the note is actually saved here on the screen. Yeah. Hopefully it works. I promise I didn't do anything to cheat around this.
As I mentioned before, Capacitor is really the next step up from what we all know as at the first initial kind of all-in-one tool. Let's get away from native. So we're really looking forward to hear more about Capacitor itself, and also to use more of Ionic that is becoming the industry standard for this kind of this kind of work. So anyone has any question apart from the beard? You had loads of comments about your beard. I have to be honest. You really nailed it on that.
I'm glad people enjoy the beard.
They did indeed. It's good. So my understanding is it seems like there are no more questions. So as Mike mentioned, you can reach out on Twitter, either himself or at Distal Labs, or personally to myself at Zelig880. We're more, the community, the web community is always open to, to talk around anything and support you guys. Really, thank you so much for joining on the last session of the year as well. This has been a very strange year, I would say, but at least, having ability to join all these meetup has helped everyone to get along. So let's hope the next year we can all meet together. I'm going to host every single one in my house. I don't think it's going to happen. Sorry, guys. Not big enough, but it's been a pleasure to be around, and we really look forward for loads of events that have been lined up for next year. And as I mentioned to you, Mike, I look forward to try Capacitor during the Christmas holiday where the kids sleep.
Awesome. Glad to hear that.
Amazing. So thank you so much, everybody. Don't forget to subscribe and to click on the bell so that you get notified when there are new videos, and have a lovely Christmas and enjoy your celebrations.